Okay, we're back on the ionospheric badge project again. These were released about a year ago, and we sold a bunch of them for a fundraiser at DEF CON. And DEF CON's coming back up pretty soon, so maybe a new firmware upgrade. This one happens to be a prototype. It is running code that's a few days old, but it has the QSO feature in it. This one over here is a production model. It's connected up for firmware development using this Seger Mini adapter, and is running the brand new code. And the difference is that when we do a QSO on this, it just exchanges the call sign and pretends to exchange a signal report. When I initiate a QSO on this, it's going to try to download a message, an actual transmission, which will come off the SD card in the remote badge. So let's demonstrate the old way. I'll go down to the nearby menu and hit enter. Here's a list of all the nearby badges. So that's a list of just this one badge that's next to it. If I select that, it offers a chance to make a QSO with this ionospheric badge. So I say yes, then it makes a connection, an actual Bluetooth connection, fetches the call sign associated with the other badge, and reports success. This little message that says you're 599, thanks for the QSO is fake, but the call sign has actually been fetched over Bluetooth from the other badge. And if I go review the log file, I will see an entry for the QSO. So that's nice, and it's fast, kind of minimal data transmission. So we wanted to add some more data transmission. So over here, I'm going to do the same thing. Start with the nearby list. There's the other badge. I select it and choose to make a QSO with it. It's going to connect quickly, and it's already fetched the call sign, and now it's fetching the data. The data is limited to 510 bytes, which ought to transfer really fast on Bluetooth, but for reasons that I haven't figured out yet, it's not fast. We're waiting for it, and waiting and waiting and waiting, and eventually the data will come through. Currently, the data does not get displayed on the little badge display, but it does get put in the log file, so we can check it. It connects right away. It transfers the call sign. That's fairly quick. If we look over here in the debugger, we can see that we're getting little responses in chunks of 22 bytes, and they're taking several seconds for each response. This is why it's slow. This gets up to 510, and then it's supposed to declare success and have transferred the entire message. I call this message a brag tape because in the old days of radio teletype, where typing was very painful, you had to prepare a canned message on paper tape and feed it through your paper tape reader in order to transmit it. And what was typically transmitted was a description of the station equipment. It came to be called a brag tape. So any kind of canned message being sent can be called a brag tape, even if you're not bragging. 286 bytes so far.
Halfway there.
I'm testing with a maximum size message. 506, and then a short packet with only 4 bytes, and it declared it was done. And we see that it says message received. It's in a contrasting color to get your attention to it, and still declares a good QSO. There's the call sign that we received. And if we then go look in the log file, we can actually see the message. Here's the log file. This contains many tests done over a period of time. These are old style QSOs that just exchanged the call sign. So I'm going to go quickly all the way to the bottom here. All right, there we are at the end of the log. So you scroll up a bit. So here's the QSO we just made. It says W5NYV is the call sign. That's the call sign of the other badge. And then here's the message that came in. And I just typed in a poem here. You may recognize this poem and see that it's garbled. It's getting the first 22 or 20 or so characters of each line on the display because the log viewer software is currently too dumb to wrap the words. That'll get better too. So this works. We're actually able to transfer a message from one badge to the other, but it's inexplicably and intolerably slow. So some work needs to be done still. And we want to display it as it comes in to give you something to look at while you're waiting. Well, we've added a feature to the badge. It's one small step toward the eventual role of the badge as a peripheral for a Phase 4 ground radio. The idea is that the badge will be able to display status from the radio using all these nice LEDs that we've provided. That means that the badge has to somehow receive data from the radio, and we've chosen to use Bluetooth for that because that's how the badge can communicate. So we currently have on the display here a menu entry for the Phase 4 badge. There's our little Phase 4 logo, Phase 4 radio. And if we choose that, then it listens on Bluetooth for advertisements from the radio. Currently, all it's doing is displaying them in text here on the screen, but we're able to receive regular updates from the badge and a small batch of data, which is represented here by our little hex string, and that data will control the LEDs. Right now, the radio is being simulated. Over here we have an ESP32, which is just plugged into the computer for power, and a small script running on this little computer that generates the Bluetooth advertisement to simulate the Phase 4 ground radio.
Here's our ESP32 development board. It's from HackerBoxes and has a TFT display, a programmable RGB LEDs, an SD card for storage, up, down, left, right, select user interface input, and some circuitry for charging a lithium-ion battery. It's a great platform for building up the executive function code for things like Phase 4 ground radios. So what do we have working? The high-resolution display works, SD card access is working, and Bluetooth advertising is working. This sends commands to the trans-ionospheric badge. ESP32 development can be done with the Arduino IDE, but this is very limited and hogs memory. For Phase 4 ground, we use the ESP IDF. This means command line, but Visual Studio Code works with some setup. This gives you context colors and build and run functions. We highly recommend the ESP32. Check it out at the link in the show notes. Our next report will be about multicast IP and SDR work. See you then.